Hi, and welcome to A Maths with Omini Wilson. I think it's a great day to understand maths better. So we are going to do a paper together, a full paper, and hopefully by the end of it, some concepts will make more sense. I highly recommend either one of these two calculators. Let me just show you what I've got. Either the FX991ZA2 plus 2, or this one, the FX991ZA plus. They do have like a few tricks. So yeah, I would prefer that you either have this one or this one ready with you. I also would like you to have the right mental space. You need to believe that you can do this. You also need a nice quiet place, quiet environment, stationery, yes, ruler, yes. Let me show you what we're doing today. So we are doing October, November 2020, paper 13. You will see in some of my other videos, I do the other two papers. Every season, like October, November 2020, has got 3 papers printed. You'll also see 1 hour, 50 minutes hour, that's your allocation. Also, you've probably read through this, but very important, just how to round off yes. Let's start with number 1A. I think we can do this. Let's stay in the zone, maths zone. X squared plus 6x plus 5. They ask us to write it in that form. Basically saying, can we complete the square? Now, please remember with completing the square, there is a long method and there is a short method. It's only 2 marks. I can quickly show you the long method just for those of you that want to see it. You take the coefficient of x, always the same, half times coefficient of x squared. Get your answer, square it. Let me show you where I'm going to use this 9. I'm going to say x squared plus 6x plus 9 minus 9 plus 5. I'm not allowed to change the value of my expression. So I'm adding 9 and minusing 9. There is method in my madness. The reason why I'm doing this is so that the first 3 terms will create a square bracket. And inside your square bracket, you use your middle step. And then you've got the leftovers. Okay, I mean, it's not a lot of marks. Let me show you how to do it on my calculator. You go to mode. First, switch it on. You go to mode, and then I need you to look at the different options there. I've got equation. This is the one I'm going to use, number 5. And then you pick number 3, the one that looks like a trinomial. You'll see they'll give you space to type in the coefficients. Check my coefficients, 1, 6, 5. Don't type in any variables here. I want to just see 1, 6, 5. Do you see I keep pressing equals after everyone? It will give you the x cuts, the x intercepts, but I'm not interested in that. I'm interested in the turning point. And the turning point is actually -3, which means that your bracket needs to be +3. And then check what is your y value at your turning point, -4. Okay, so just confirming -4. Also on the memo, you'll see 1, 2 marks. So there's no problem in just quickly doing the shortcut. If you're in an exam and you are stressed for time. All right, first one done. You can obviously draw a little sketch if you need it for the next question. Let's just see, because this does represent a parabola with an actual turning point. The next one is quite interesting. They say B. They talk about transformations. Now, transformation is new to the syllabus. So it's just theory work you have to go and study, especially my students, go study it. Externals are coming up soon. I would love to see that curve looks familiar. I think this curve is what we were just doing, right? We were just rewriting that in that form. So what they're basically asking you is, what happened from y is equal to x squared? What's happening from this, y is equal to x squared, to suddenly become this? Now, if it is plusing and minusing and not timesing, then we know it was a translation. So I hope that you will go and study this chapter. It's a translation through vector, and then you just say -3, -4. If you want a little bit more explanation, you basically had a parabola that goes through the origin, and now you've got a parabola. Remember, we were speaking about the turning point being at -3, -4. So what has happened? Okay, visually you can see it moved this way and it moved this way. So that's why you go -3, -4. Translation. And that's good enough. I mean, yeah, don't do anything extra here. It's only 2 marks. Let's see if we are on target. Yeah, just translation, 1 mark, or shift. I don't mind if you don't know how to spell translation. Then you can just say shift, but the vector is important. Okay. Number 2. Okay, I thought they're going to ask us more things there. Maybe like inverse, but not today, not today. Let's do number 2. They ask us to do f of x. Let's just copy that little equation down. 2 over x plus 2 to the power 2. There's a restriction on your domain. X must be bigger than -2. They want us to integrate this. I feel like I might have to rewrite my bracket. I'm bringing up, you'll see what I do, but I'm bringing up my power and making it negative. So denominator can come up. We're doing 1 to infinity, which might stress a few of you, but don't worry, I'm doing this with you. Okay. This is what I've got. Did you see how I rewrote that? Just so I'm able to integrate. Infinity is difficult to actually deal with. So can we rather just say, I'm going to make you just A, alpha or A, and later I will consider infinity, because it's difficult to think about infinity at this stage when we still have to integrate and all of that. So let's integrate. If you integrate a bracket, I want to remind you of reverse chain rule. If you do reverse chain rule, you add 1 to the exponent and you divide with your new exponent times by 1 over coefficient of x, but this value is just going to be 1. I almost said x, but it's the coefficient of x. So this doesn't really matter, but I want you to get into the habit of doing that. But we still need to do our boundaries. If we didn't have boundaries, you'd have to say plus c, because then it would be an indefinite integral. All right, let us just quickly clean this up a bit. It will be like this, -2. I'm going to sub in my a plus 2 minus 1 minus, remember you always sub your biggest boundary in first and then your smaller boundary. Check the double negative. The negative comes from you subbing in your second boundary, and the negative comes from what you just created. So I've basically got this. Oh, but I forgot to sub a 1 in. Okay. So we're subbing in our boundaries. Also keeping in mind that if you want to, you can drop it down again. If you're struggling to do it, you can drop it down like this. -2 at the top. And this one at the bottom, I'm going to just quickly work this out. It's going to be 1 plus 2. It's going to be 3. Right. Okay. Now infinity can come and play a role. Remember, we did say infinity was A. Now here is infinity. If you type in something very big into that place, if you sub like 1,000 or 1,000,000, let's type that into the calculator and see what will happen. I can promise you it will become insignificantly small. The fancy definition is if you have a finite numerator with an infinite denominator, it will always equal 0. So this will become insignificantly small. And then all that remains is this guy. So the answer is actually an estimated 2 over 3, because technically this is still has a value, but it becomes insignificantly small. Yeah, it's not a lot of marks because, let me just quickly check if we were on track. Yeah, you can just make it 0. But just know why it became 0 is if you have an infinity in your denominator. Lovely. Okay, let's go on to the next one. It's still the same equation, but just check. We're going to probably have to derive now. The equation has a curve. They're being sneaky. They're saying that this curve has technically already been derived. So they say dy dx is the f of x that we were just working with. So this is my already derived version. And they say it is given that that point lies on the curve. So we can't use this -1 for my immediate equation because it's derived. If you want the equation of the curve, we'll have to integrate again. So, I mean, you can integrate again, or you can just check what you previously had. Just check how I wrote this down. And now with my new version, I'm going to integrate, but last time I had an integral and I just dropped it when I integrated. This is another way. If you have dy dx and you integrate, you call it y, okay, antiderivative. So let me just quickly do it again. So you go 2x plus 2, add 1 to the top, divide. This was my integration from the previous question. But now you have to put plus c because you don't have any boundaries. I also have a coordinate that you can use. You couldn't use it in the original because this is technically gradient and x, but this is x and y. So I would love to sub that in -1, sub that in -1, and then you can work out what c equals. But that's easy, right? I'm not going to do that with you. I'm just going to quickly check what you're supposed to get to. C must be 1. Okay. Easy, easy, easy. That was my integration question sorted. So c is equal to 1. And then just write the equation down of the curve and then you'll see at the end. Let's move on to number 3. Trig. Trig can be tricky, but we can handle this. Number 3, let's do this together. We've got 3 tan squared theta plus 1 equals, just make sure, they say solve the equation, not asking prove or show that, because you must make sure the instruction is read carefully. You must not try and do left hand side, right hand side in this case. You just have to solve it like algebra. So this is where algebra and trig actually meet. We do have an interval, which means later we're probably going to have to use specific solutions, but we will get to that. Have a look what I've got. Okay, first things first, if I see tan squared, I really want to get, tan squared in a denominator, I really want to get rid of it. So I'm going to times everything with tan squared. That's the easiest and most effective way to get rid of a denominator. And then this one is just normal 2, but I'm going to bring it over -2, so then it becomes a denominator. Oh, becomes a trinomial. We got rid of the denominator. We are going to make nice brackets now at this stage because I did identify that it's a trinomial. You can see if the power is doubled on this side and there's nothing on the other side, it is a trinomial. Now, earlier we were working with this calculator and I showed you how to use mode 5, 3. This helps you to get any trinomial. For instance, this trinomial 3, 1, and -2 are still your coefficients, even if it looks weird. 3, 1, oh, short-term memory loss, -2, -2. See what you get? I get a fraction. So let me help you deal with a fraction. Obviously, they say on the calculator x is equal to something, but we are going to say not x, but tan squared theta. Remember, you still need to use your own brain. Hey, that's just helping you. Tan squared and tan squared will be the 2 brackets, and then your answer will have to be tan squared. So I got 2/3 from the calculator. But what needs to happen inside your bracket, just move this 3 back and then say -2. It's almost like you're deconstructing it. If you try to solve this, you take that over and divide by 3. But now to make the bracket, we do the opposite. The other answer I'm getting, let's just press equals again. My other x, my x2, is -1. So I get tan squared theta is -1, which means my original bracket should look like this, +1. For those of you old school, if you wanted to do this the hard way, no calculator, that times that must give you that. That times that must give you that. And outer and inner, so inner and outer must produce the middle one. Okay, don't be put off the fact that there's tans. It doesn't matter. You can still do trinomial work with this. Let's go slightly further. Square root, oops, not applicable, imaginary. Let's try this one, square root, that does work, but be very, very careful. If you do square root, I need 2 answers from you. So let me just show you what I've got. I've got a tan on this side. That's going to equal +2/3. And then I've got another tan, maybe you should split them up like I do. That's equal negative, square root, square root 2/3. Because as soon as you square root, actually in this step, I want to already see plus minus, please. Okay. At this stage, we do need to get to a reference angle. So how do we do that? On your calculator, you just go back to mode 1, and then I want you to go and say Shift Tan. Okay, check the button. Shift Tan, it's also called arctan, the fancy name. What basically happens is you are dividing with a tan to get theta alone. So this is called my reference angle. So the button is very important. And then you just type in square root 2/3. So you see where to get the fraction. And then I get, just make sure also at the top here, there must be a little d for degrees. Later we will be working with radians, but I get 39,23. Later we will round off to 1 decimal because it is degrees. For your tan, I want you to remember, you will say plus K180. This will give you all the other all the other answers that can possibly happen on the tan graph. Tan is the only one that says plus K180. We will be doing, when we do other papers, we will be doing cos, the shortcut for cos and the shortcut for sine. But this you have to memorize. This is what you do when you're dealing with tan. By the way, the K will always be an integer. This will help you get all the values that you need. Let me show you how to get the negative. Negative, if you just put a negative in there, you can even move around it. You see, I use my cursor. I get negative 39.23. That's fine. Negative 39.23 plus K180 because we are dealing with tan. Remember, the original question said you have to work between 0 and 180. So I'm happy with you selecting this first answer. You don't have to add anything. You can put a 0 into K. That means this is my first answer. But this one is not in my interval, but I can make it in my interval by putting a 1 into K. So if I take my answer that I previously had, you can just on the calculator just say plus 180 or 1 times 180. It will already think about the previous answer that you had. I get 140,7. Oh, I need to do 1 decimal place. So I'm going to say comma 8. And this one will be comma 2. What will happen here, remember you control the K. It can be 0, 1, 2, -1, -2. Just make sure 2 will not work because my interval, remember earlier we had an interval of 0 to 180. We can't go larger than that. I'm happy with just sticking to adding a single 180 and nothing else will work. You can also check on the mark allocation to see sort of how many marks will be needed. It's 5 marks. There's a lot of algebra that was involved. Check 2 marks for the answer. The plus minus was very, very important. You needed to be in degrees, not in radians. That's it. That was 3. I like that question. Okay, let's move on to 4. I do need you to recenter every now and again. Take a deep breath. Your brain does need oxygen. And so does your mental state. Just like a quick breath. Okay. Curve has this equation. Let's write that down. 3x squared minus 4x plus 4. And we have a straight line y is equal to mx plus m minus 1, where m is a constant. They ask you to find the set of values of m for which the curve and the line have 2 distinct points of intersection. Okay, so if they talk about point of intersection, I want to remind you that we have to set them equal to each other. This is very important to remember. Point of intersection, you set the 2 equations equal to each other, or we basically sub the one into the other. We sub this y into that y. That is what we're doing. Also, if you want to just quickly bring everything to one side, because if you want to analyze what is happening, let me just quickly concentrate here. Bring everything over, don't make a sign error. If you want to analyze what is happening with this point of intersection, I would advise going into discriminant, because discriminant b squared minus 4ac or delta, it helps you see the nature of roots that happen at this specific point of intersection. And this is also theory. This is something you have to go and study. If you want 2 distinct points of intersection like this, you want your delta to be bigger than 0. There are other options I've mentioned before. If you have only intersecting once, it basically is a tangent, then delta will equal naught. Or if you don't want them to intersect at all, you just make delta smaller than naught. It's theory, go and study it. But for my question, they do focus on intersecting at two distinct points. Also, something I want to remind you of, let me just get a color here. I want you to remember that this will be A. The coefficient of x squared is A. The coefficient of x, even if there's more than one, will be B. So both of these will be B. And then something that doesn't have an x will be C. So you need to know where your A, B, and C will be so that you can do discriminant. For my B value, only take the coefficient. Don't bring, I don't want x's here. Hey? No x's, only do coefficients of x. Say, okay, so b squared minus 4ac. Got it. And then you take this and you say you have to be bigger than naught. So this becomes an inequality. If you times out the bracket and you're scared that you're going to get this wrong, you can just write two brackets next to each other and just FOIL. Or let me show you a shortcut. Square the first. Square the last. But that's not all. That times 2. So I've got 4m times 2 is 8m. That's it. And then I've got my second one. This is 12. I'm going to positive and a negative 12. I'm going to distribute that into my bracket. That's going to become negative 60. This is negative and a negative. So it's going to become positive 12m, bigger than naught. Okay, and then I'm just going to rearrange it. Remember, at this stage, if there were any negatives in front of your m squared and you had to get rid of it, this would have also swapped. Remember, this is sign sensitive. So if you times everything with negative, this can also switch around. Okay, I've got this, and then 54, right? No, 44. I'm used to having a class correcting me and saying, no, you're wrong. Yeah, it's negative 44. So then I'm just going to leave it like that. You are then welcome with inequalities to just do normal mode 5-3. But there is another mode for inequalities that I'll show you now. You can just do normal mode 5-3. Type in your coefficients, 120, negative 44. Okay, so my two critical values that I get is 2. So I know my 1m is 2. So I know the bracket was negative 2. And then my other bracket is get an answer of negative 22 from the calculator. So this is going to be positive 22. So I'm going to show you the long method because I do need you to know how to do this manually. And then I'll show you the other shortcut. You've got negative 22 here, 2 there. You sketch it, you say bigger than. So that means above the line. So then you've got m smaller than negative 22 and m bigger than 2. That's your answer. But now I want to show you something great. There is a mode that you can go and then go down and find inequalities, which is number 2. And we are doing quadratic, not cubic. So you pick number 1. And then you're looking for something that looks like this, bigger than. So we're picking number 1. And then you just feed in your coefficients once again. I've got 1 and 20 and negative 44. Do you see how I type that in? And then you just press equals again. Check. X must be smaller than negative 22. X must be bigger than 2. Don't write it like this. Write it like I did. And then you've got it. Except remember, we must change the variable. The variable is m in this case. Nice to have a friend with you that can go into the exam with you, because I can't. Please don't take me into the exam with you. Okay, I'm done with 4. I'm moving on to 5. 5 looks like they're combining some chapters here. I think they're going to start combining binomial with series and sequences. It happens. I always tell my class, I can't make Cambridge papers easier, but I can make you better. So let's try and make you better. In the expansion of a plus bx to the power 7, a and b are non-zero constants. I've got coefficients of x and x squared and x4 that they say form a geometric progression. Okay. Interesting. They have this that we probably need to expand. And once we've expanded it, these will become term 1, term 2, and term 3 of a geometric progression. First things first, I just like, when I see binomial, I just like to write out the first few. Probably not going to expand all of them. But I want to remind you of how this works. So it's to the power 7. So you can start with 7 naught, but also your first power for your first bracket is also 7. The next bracket is that one minus that one, the next A. It keeps going down in powers. So if you want to write a few of them, this is what I want to see. The second one, the BX, second bracket, starts with the power 0. Then it keeps going up in power. So it really, if you've done this a few times, it's not difficult. Just keep your wits about you. Bracket usage is important. Also, just remember this one goes down as this one goes up. This one minus this one gives you that power. That bottom number coincides with this power. Lots of things to check. Also, the first question said we need to look at the power of x, x squared, and x4. So we're only going to do the ones that actually produce x, x squared, and x4. None of the others. So only expand those 3. Don't waste your time. There could potentially be 8 terms here, but we're not doing all of them. Let me show you the formula sheet on your Cambridge formula sheet tells you how to expand this, but the shortcut is just go mode 1 to get back. The shortcut is just going, what was it, 7, 1. 7, shift, divide 1. It gives you 7, choose 1, which gives you 7. Okay, so this is the shortcut to get these little numbers in front. A6, BX. Let's do this one, 7, 2. You can just erase it and put a 2 in there. I get 21. So 21, A5, B squared, X squared. I hope you didn't forget to put a squared there. And then we're quickly going to do 7, 4. I'm just going to do it on the side here. 7, 4, I get 35. A3, B4, B, don't lie, X4. That will be the expansion. Now, please remember they did mention geometric. So geometric expansions has the statement of a constant R. And an R, or the ratio, can be done by just doing this. Term 2 divided by term 1, term 3 divided by term 2. That will give you the constant ratio. Now, if they say that these terms or the coefficients of these terms are geometric, we're allowed to use this statement. Only the coefficients though, so I'm going to say this is term 1, term 2, term 3. I'm going to take term 1, which is this, over, I'm going to take term 2 divided by term 1, B, is equal to term 3, only the coefficient, over term 2. Nice. So then what we can do, there's multiple ways of solving this, but I would have maybe just simplified each side a little bit. 7 goes into itself once, it goes into 21 3 times. A6 will just become A, B, cancel it there. So the only thing that's left over here is 3B over A. I hope you're still with me. This is ICSI work. Then here, what can we use? 7 goes in there 5 times, goes in there 3 times. And then for the A's, this one will win the biggest power. And for the B's, that one will win biggest power. Okay, let me just quickly go back to the question and see in what way do they want me to answer this. Find the value of A over B. Okay, we can do that. So let's try and find A over B. Perhaps let's times the A squared there. So this will be 3A squared B over A. And then let's divide. Remember, if you can also think of it like this. You times by A squared over B squared on this side so that they cancel out. But if you do something on this side, you have to also do it on the other side. A squared over B squared. I hope that makes more sense. And then you go top times top and bottom times bottom. That is what I've got. Cancel, 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 cancel.
And then this 3, if you want to get rid of it, just divide by 3 on both sides. So if you divide by 3 on both sides, I get 5/9. Let's hold thumbs that this is accurate, because I do tend to make mistakes if I'm not in a live class. Because, yeah, 5/9. High school students are normally very vocal about when the teacher goes off track, and when I make a mistake. So I've got a bunch of spell checkers or maths checkers normally behind me. But this is also good because I can just go on and match with the memo. Let's do 6. I think we're halfway. 6 out of 12 questions. Let's write down f of x. So f of x is 2x over 3x minus 1. There is a domain restriction, x must be bigger than 1/3, and we want the inverse. Make sure that that's inverse, not derivative. With exam stress, I know that this symbol can start looking like an apostrophe. It's not, it's inverse. And the first step for inverse is transposing x and y, but that just means swap x and y. Every x becomes a y, every y becomes an x. So I want you to notice what is happening here. That's the first step, step 1. Step 2 is try and get your y alone. I do not like working with fractions, so I times my denominator to the left-hand side, and then I try and get y alone. So everything that has a y, I'm going to bring over to this side. And everything that doesn't have a y, like this x, I'm going to bring to the other side. So what have I got? 3xy minus 2y equals x. And then I just do common factor. As easy as that. And then to get a y completely alone, just divide by 3x. 3x minus 2 on both sides. So this is my inverse. Okay, you can write it, if you wanted to write it fancy, you can now call it inverse of f and then say x over 3x minus 2. That wasn't difficult. Inverse is normally not difficult. Finding the inverse, I know domain and range can get tricky, but finding the inverse is very nice and easy. Okay, they also ask us for B to do a little bit of algebra. They say, can you show me that that can be written as that? I'm noticing 2 fractions, 2 over 3 plus 2 over 3, 3x minus 1. They want you to make that become 1 fraction. Okay, so do you see there? 2 fractions need to become 1 fraction. So the first thing I'm noticing is I can do an LCD. LCD is basically taking this denominator, putting it together, and then asking myself, what do you need from the denominator or the LCD? You need the 3x minus 1. What do you need? Nothing. Okay, so then you can just distribute a little bit. This is going to become 6x minus 2 plus 2. Okay, and then you can, let me just see, what am I supposed to get to? I am supposed to get to 3x minus 1. Okay, so I think I'm going to keep the 3 in front because they do want me to cancel something. They want me to just simplify this. 3 goes into itself once, goes into 6 twice. And then I'm there. I mean, some of the questions are very easy, almost like suspicious. Why did you make me do this? This is easy. So this was B. I did prove or show that the first one can become the next one. This is not a left and right hand side where you can work with both sides. You have to show that the original becomes the new one. And then they want the range of f. Okay, so they did say for the range of f, we need to look at the original. The original one had a restriction of x being bigger than 1/3. So that obviously applies to this new equation that we made, that was originally actually given, this one, 2x. You can try and get the range from him, or there must be some reason why they made us rewrite this. They don't normally do that just for nothing. So I will do this in 2 methods. It's just 1 mark, so it shouldn't take you very long. If x is 1/3, do you agree that this will be almost like undefined, so it's very, very close to 0? So I would say if I just look at where x is heading, x is going to keep being bigger than 1/3. So the smallest value that you can get to will be 2/3. And then bigger than 2/3 as soon as you sub in values where x is bigger than 1/3, I would then say that y tends to bigger than 2/3. If that makes sense, great, go on forward the rest of this video. But I would want to show you the other method, the manual method, if you don't understand what I just said. If my y equals this, and my x has to be a value that is bigger than 1/3, I want you to take some values that are bigger than 1/3. Maybe take a value that is very, very close to 1/3, like maybe take 0.334, and take a value that is much, much, much bigger than 1/3. Just to observe when this happens, what happens to my y value? And this is something you can just take this value, sub it into x, and see what you get. So I'm going to say 2 times 0.334 over 3 times 0.334, and then minus 1. So I get something that's quite big, like 334. And then I'm going to take the same thing. Let me just show you how I typed that in, by the way. I just subbed in 0.334. But now what you can do is you can move back with this cursor and just make it 1,000. Or whatever you chose. It can be bigger than that as well. And then this will also be 1,000. Maybe a little bit bigger because I wanted to show you something. Make it 1,000,000. So if it is 1,000,000, yeah, it's basically 2/3. That's what I wanted to show. So even if it's 1,000,000, I get 2/3, which means the lowest value my y can be is 2/3. And then after that, the smaller this one gets, you can even try like 0.333334. This value will get bigger. And that's the problem with people. They don't understand that as you control a fraction, the denominator does control it as well. So what I mean is if the denominator gets bigger, like what we have here, the x is bigger than 1/3, the whole number actually gets smaller. So the biggest that you can be is 2/3. After that, the number is just going to get bigger and bigger as your denominator gets smaller, if that makes sense. Okay, let's move on. Let's move on to the next one. They ask us for question 7. They say the first and second terms of an arithmetic progression are, let's just check that, 1 over cos squared theta. So we've got that as first term. And my second term is negative tan squared over cos squared. Okay, that's my first 2 terms of an arithmetic progression, so constant difference. And this is very important to notice. We have to work in radians, because if you see a pi, we need to be in radians. And they want us to find the common difference. Okay, I've written down term 1, term 2. So please remember, if you want the constant difference in arithmetic, you say term 2 minus term 1. Or you could have said term 3 minus term 2. So what I've got is I've got term 2, which is this, and negative. I'm going to change the tan into sine squared over cos squared. That's now for term 2. And then it's over cos squared. So I'm going to say divided by cos squared. I hope that makes sense for you for term 1. Minus term 2. Term 2, I'm not going to change at all. I'm just going to leave it as is. Okay, let me just move this up a little bit so you can see. Let me show you what I'm going to do with term 2 some more. You know, I can say sine squared over cos squared times by 1 over cos squared. Because if you're timesing, check, then you have to basically flip this one. Flip and change, or whatever you call it, tip and times. You times it and then you take the denominator up and the numerator down. That's what you can do there. And then I've got here still cos squared x. So what I've got at the moment is top times top and bottom times bottom. And here I'm just going to leave it like that. It does look like the one that they want is 1 term. So I'm going to do an LCD. And my LCD is going to be cos 4x. What do you need? You need nothing. What do you need? You still need a cos squared. What I talk about is like the denominator to get to this denominator. Then what I can do is I can take out a -1 at the top. Then I've got sine squared plus cos squared, which gives me 1. And then I've got what they wanted. This is my constant difference. That is it. Constant difference, yes, or common difference. That is what I wanted for 7a. Then for 7b, they want the exact value of the 13th term. Now, when they want the 13th term, you need your Cambridge formula sheet close by. So we want term 13 for arithmetic if theta equals a 6th pi. Okay, so let me show you what I've got. Term 13, there is a formula a plus n minus 1d from your formula sheet that you can go and look at. If you also notice that you do have a from your previous question, so let me just quickly say, a is term 1, n is number of terms, d is constant difference. My a was 1 over cos squared, but you can sub in your theta. N in this case is 13, so 13 minus 1 is 12. And my constant difference you just found for me is -1 over cos 4, 1 over 6 pi. Okay, first things first, when we want to type this into the calculator, you need to be in radians. So that's going to be a new journey. You're going to go shift, setup, no. You're going to go mode, and then you choose, you do go shift, setup, and then number 4. Okay, so I hope I didn't confuse you. Shift, setup, number 4, which is radians. You'll also see at the top there's a little R that tells you that you're on radians now. Let's type in this whole thing. So 1 over cos squared, have a look. There's no shift cos, you just go 1 over cos. I know you can't say squared, so I'll show you where to put the squared. You can put the squared at the end. Okay, and then you just move on, and then you type in plus, and then all of this, plus 12 bracket, and then I'm just checking what I'm supposed to type in, 12 bracket. Let me just do it on the side, then I'm quicker. At the top, -1 at the bottom. Remember the same thing, you can type in cos 1 over 6 pi, and then close your bracket, and then make it to the power 4. And then just close your bracket at the end. I'm going to show you what I've got. Yes. And then go equals. Then let's see what we've got. -10.73. What do they have? Let's see. -20. Perhaps I typed in something wrong. Let me just quickly check. Found it. Be careful when you type in where your pi needs to go. Check. It's 1 over 6 and then pi. Okay, so that's, you can learn by negative example. If I get it wrong, you're not supposed to get it wrong. -20. Okay. If I do make mistakes, then you also just know that I'm not an AI. I'm a real person doing this with you. Happy with B. Yes. And then we can go on to 8. I always feel if we get to 8, we've already done the bulk of the paper is behind us. Deep breathing. Let us try. Y equals 2x plus 1 plus, I'm going to bring up that bracket because I can tell we're going to have to derive, and there is a domain restriction. They ask us to find first and second derivative. Oops, okay. So what I've got is, I brought this up and we're going to do first and second derivative. Very easy. First derivative, remember we're deriving, we're not integrating. So how do we derive? You take your exponent times to the front, subtract 1. Constants will fall away. If you do have to derive a bracket, you first derive the physical bracket. So you times to the front, so that's going to become -1. Then you subtract 1 from the exponent, so times to the front, subtract 1, copy and paste the inside, and then times by the derivative of the inside. And then also we need to do second derivative, but maybe we can clean this up a bit. Times to the front, so it's 2 No, I've already, what I meant to do, never mind. I wanted to clean it up a little bit. So then I'm just going to go 2 times that to the front. I almost tried to derive again. So this is actually what I wanted. So you go 2, this 2 can join this 1, so -2. And this is still first derivative. Now I can do what I wanted to do. I'm going to derive again. And when I derive, constants fall away. And then look, chain rule again, shortcut chain rule. Times to the front, you times to the front for the exponent, and then subtract 1. And then times by the derivative of the inside. And that's it. And then what I can do to clean it up, I can just do this. Times to the front. All right. So that's first and second derivative. You can also check the notation is quite important. And 8a done. For 8b, I want you to focus on this word, stationary point. Stationary point basically means where your gradient is naught. So you need to know that this does represent your gradient. And so does this. I'm even going to call it gradient. So first derivative is gradient. And if you want stationary points, you need to make gradient equal to naught. If you can remember that, I mean, they ask this in every paper. Derivative equal to naught gives you stationary points. So I'm just going to take my first derivative and set it equal to naught. Have a look, I'm dropping down this bracket just to make it easier to solve. Then I'm going to bring this whole thing over, and then it just becomes algebra. Algebra, 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 like that. Many methods to solve this. Maybe you can just times that denominator to this side to get rid of it. Divide both sides by 1, by 2 to get 1. So divide by 2, divide by 2. Then you can even square root. I'm going to square root. So then I get plus minus 1 equal to 2x plus 1. Remember when you square root, even here, put plus minus, don't lose half your answers. So then the 2 answers I'm going to get is 2x plus 1 equals 1, 2x plus 1 equals -1. Remember the 2 answers. So my 1x, if I bring that over, it's 0 divided by 2 is 0. My other one is -2. If I divide it by 2, is going to give me -1. Let's see if there was a restriction. I do remember reading something in the beginning about the x. Yeah, x needs to be bigger than -1/2. So I don't think we can use that -1, to be honest. I think we must only use the 0. Yes. Okay, so only use the 0 because there was a domain restriction. X must be bigger than -1/2. So if I have to choose one, I'll only use x equals 0. We also need the coordinates, right? They didn't just say x coordinates, they said full coordinates. So I also need the y. So if you want to find the y, we need to go way up to the beginning here when we still had y. So I have a 0 in for me. So this is 1 plus 1, basically. You can use your calculator, but I think you can use your healthy brain as well. Y is equal to 2. Then we also need to classify the stationary point. Remember, this one's not applicable because it didn't pass the domain restriction. For concavity, I hope that you know that first derivative is gradient. This represents gradient of the curve, but second derivative represents concavity. So if you put a naught in here, it will talk about the concavity of the curve at that specific point. I do get an answer of then 8. Yeah, if I work it out correctly. My second derivative gives me 8. Maybe let's just write that down. My second derivative was bigger than naught because it gave me 8. So that means it's concave up, which means you have a minimum turning point. So I want to just see here, minimum turning point. Yes. Let's see if we got all our marks that we were supposed to get to. Yes, we did. And that was question 8. That was the nice calculus question. Let's move on to question 9. Here we need to keep our wits about us for problem solving. Unfortunately, I can't help you to solve your problems. That'll just come with time, and you need to have a strategy in place when we get to these type of questions, like what are we going to do? The plan is the most important part. They say in the diagram we've got arc AB, and it's part of a circle with center O. So we've got arc AB, center O, and it has radius 8 and 8. Nice. Then we've got arc BC with center A, radius 12. So that's 12, and important, this is also 12, don't forget. So OC is basically 4. And then they say where AOC is a straight line, thank you. And we've got angle BAO, we want that in radians, BAO. So can you find that little angle for me? Little bit of a problem, we don't have any other angles. So I think we need to do the cos rule. The cos rule is perfect if we have 3 sides and we need an angle. So if we have 3 sides, this is the cos rule. You might remember this from IGCSE. This is what I've got for the cos rule. Please notice that this is a side and this is an angle. And all the lowercase letters are all sides. So when we do this one that I was just speaking about, if you want angle A, this one here, you have to start with his opposite side, so basically with 8. And the rest, the 8 and the 12, it doesn't really matter where they go. But what is important is that you start with 8, and then the other 8 can be anywhere, and then there's a 12. So you sub all the sides into the lowercase, and then this one will be the uppercase, the angle, but we don't know the angle. Lots of things to do on the calculator. You can go 8 squared minus 8 squared minus 12 squared. I'm just going to quickly type that in. 8 squared minus 8 squared minus 12 squared. I get negative 144. Be careful, you can't just take that over as well. This is tied to the cos with the times. So you have to divide by. So I'm going to divide by, let's just work that out. 2 times 8 times 12, the negative 192. Nice. And then if you want your angle, remember then you bring your cos over. So you're going to go arc cos on your calculator. You go arc cos of this angle. Let me just show you what I'm typing in. You go arc cos of, and please still be in radians, negative 144 over negative 192. Okay, so I get 0,722. And that's actually the only thing they asked there. Is the angle BAO. And we're going to use that a lot going forward. Now, oh, okay, check my rounding off. They do want you to do 3 significant figures. So this is what I've got, 0,7227. So please be accurate. I'm not going to teach you how to round off anymore. You need to do 3 significant figures correctly. Okay, I think that's going to help us a lot going forward. Because now we have this little angle. They ask us to find the area of the shaded region. This is now for 9B, area of shaded region. Okay, we need a plan. Plan. What about sector? Sector area is something you have on the calculator. Minus triangle. I know we don't have a triangle 90, but we can still do area of a triangle. So let's write down our plan. We need to go area of shaded, and then let's write down our plan. We're going to go sector. What was the sector's name again? Was it ABC? Sector ABC minus triangle. And what was the triangle? AOB. Okay, so it's like I said, the plan is very important. Now we can bring in some formulas. Sector area is a half r squared theta. Theta needs to be in radians. And for a triangle with no 90, I want you to use half a b sine c. Again, side, side, angle. And this one is quite specific. It's side, side, interior angle. So when you have that already, we can look at the sketch again to see what radius we're going to use. Please use this radius, 12. I'm going to say a half 12 squared, and my theta is what I just got, 0,723. That's this angle, the angle that is basically subtending my arc. Then I'm going to say a half times, this is now for the triangle. I think for the triangle, you must be very careful because we still need to use this angle. So we need to use 12 and 8 because it needs to be the interior angle that we put into C, 0,723. Okay, so I'm going to show you what I've got, and then you can just type it into the calculator and see what you get for area of shaded. Remember, this is not arc sine, this is normal sine. Type it in as is and see if you match with the memo. I want you to get to 20.3. Okay, everything is the same. You'll see where you get your method marks from. It is important to look at the memo, not as often as I do, but to look at where you're going to get your marks from. Okay, I'm happy with that one. I'm happy with 9A and B. Now they want perimeter of shaded. So perimeter of shaded, we just need a plan again. It's now for 9C. 9C. Perimeter, let's say it's going to take basically an OB plus an OC plus arc BC. That's my plan. Some of it we've already got. Remember earlier we said OC is going to just be 4 because of the radii. OB is just 8 because it's given. So arc BC, it has a formula. Arc BC, you just take radius times theta. So that becomes very easy, very quickly. Your radius is 12 and your theta is 0,723. That is your perimeter. You can quickly type that in and see if you match with the memo. 3 marks for that. Let me just quickly see if that can be possible. Yeah. Okay, not a problem. That was nice and easy. And we are in the teens. Yes. I love being at question 10. Then I know only 1 or 2 more questions to go. But I have to tell you, I do these videos in one session. So I can also feel with you, I'm getting tired. I'm starting to make mistakes. So this is very real. When I get to 10, I also start feeling tired. So breathing helps. It really does. Let's write down that horrible equation. Y is equal to 1 over k, x to the power of a half plus x to the power negative a half plus 1 over k squared, where x must be bigger than 0 and k must be a positive constant. They give us x is a quarter, and they tell us the gradient of the curve is 3. So m is 3. And then they want you to find the value of k. That's fine, except I can't really use my gradient yet, except if I maybe derive this and get my gradient. So if I derive all of this, I will be able to use my gradient. Deriving means you times to the front. I'm just going to write it like this for now, and then you subtract 1. The same here, you times to the front and subtract 1. And then remember, this is just a constant. I don't derive this at all. We are deriving the x variable only. They do tell us my gradient is 3 and my x is going to be a quarter. So I'm going to sub a 3 into dy dx because that is gradient. Here I'm going to just say top times top and bottom times bottom. I'm going to sub my x in. I hope I'm not doing too much in one step. I don't want to lose you. And then sub all of that in. And then find k. Now k is a little bit tricky to find because it's like inside here. But this is easy. Type this into the calculator. I'm pretty sure that's just going to be 2. But just to confirm, use a bracket 1 over 4 to the power of negative a half. Yeah, I get 2. So this is a half, or 1 over 2k. This is just 2 minus a half. And then you can just do, let me just show you. I typed it in like this. And then if you want to quickly change your bracket to 2 over 3, just delete it. And then rather put a 2 over 3. Let's see. Okay, I get that. It's going to be 2.51. But that's horrible. Oh, you know what I did? Mustn't do copying errors. I told you, by the end of the paper, you do get tired. It should be 3 over 2. Okay, so just go back. Make it 3 over 2. I was actually hoping for like nicer numbers here. Okay, so I get 8. That's great. And then what you can say is basically just a little bit of solving. This is 2 over 1, cancel, cancel, 1 over k, minus 4, 3, 7. I hope I'm not going too fast. Then normally if it's like this, I just flip both sides. So this becomes k, and this becomes 1 over 7. I hope that made sense. Lots of algebra for a calculus question. 1 over 7 is good. Yes, let's keep this momentum going into question 10b. Same equation, same amount of fractions and things, but this time we need to integrate. Okay, so we need to integrate. Check your boundaries, k squared and a quarter k squared, and then we've got the same equation as before. But remember, the instruction is completely different. Here they want you to integrate. And once you've integrated and applied your boundaries, you can set it equal to 13 over 12. And then we're supposed to solve k again. But obviously not the same, it's not the same k value as before, because now we're integrating. Okay, so when we integrate, remember it's a different rule. It says we need to add 1 to the exponent and then divide by that same exponent. Don't forget about the 1 over k. Same here, add 1 to your exponent, divide by that same exponent. And here, don't let the constant fall away. The 1 over k squared just gets a variable, because technically this is x to the power 0. So then you add 1. This is what you get if you integrate correctly. Remember, you still have boundaries, and these boundaries are quite intense. And then you can set it equal to 13 over 12. Okay, so let me just show you. Set it equal to 13 over 12. We are going to sub in these boundaries. Biggest one first. The biggest one is always at the top, minus this, the bottom one. But what is going to be important is your bracket usage at this stage, because there's a lot to sub in. You can also clean this up a little bit by letting the 2 join the top. Also, if you want, you can write that it like this, 1 over k. So you can rather say top times top and bottom times bottom. This 2 can flip up. But I mean, I'm doing a lot of fancy things here. If this is confusing you, you don't have to do it. I'm also subbing in k squared for now. All right, that's term 1. Term 2, like I said, the 2 can just flip up. And then I am going to sub in my k squared. And then the same here. 1 over k squared times by k squared. So k squares go into all the x's, and then I'm going to minus bracket, and then I'm going to let this go into all my x's. So my first term, I did simplify it, but now into my x, I'm putting a quarter k squared. Okay, be meticulous when you work. I'm talking to myself as well, because I also make mistakes. A quarter k squared goes in there. And I did let the 2 flip up, right? So this is just going to have a 2 in front. And then plus 1 over k squared, quarter k squared. Yo, okay. I hope you can still all see that. I'm going to have to move the camera a bit to this side. Let us do it step by step. First term. Even this little exponent here, you can type into the calculator, but the 2's will just cancel. So this is going to become k cubed. So 2 over 3, k cubed over k is just going to become k squared. Then, next term, to the power of a half and squared, if you times them, it's just going to become 1. So this is just 2k. And this is just going to be k squared times 1 over k is 1. Okay, so I'm doing it step by step. Minus bracket. Let's do all of the insides here. 1 over 4, this is something that you might want to type in. 1 over 4. To the power of 3 over 2. I think we did it earlier. Was it 8? Let's see. It's 1 over 8. So 1 over 4 to the power of 3 over 2 is going to give me 8. Why do I have... last time it was 8 because we had a negative power. But this time, if you type in a quarter to the power of 3 over 2, you should get 1 over 8. then this squared must also be affected by that power. So that's going to give me k cubed. All of this still over 3k. We can sort that out a bit later. Plus, now we've got a 2, a quarter to the power of a half. It should be 1 over 2, but let's just check. A quarter to the power of a half is a half times 2 is just going to be 1, and k squared, that's just going to be k. Yo, this is working out nicely. And then here, the k's will just cancel, so I've got a quarter, and that's about it. Okay, let's see what can happen. If I look at the bigger picture here, maybe I can sort out this one a little bit more. At the top, I've got 2 times 1 over 8. So let's just type that in, 2 times 1 over 8. And then I'm going to divide by 3. So this is 1 over 12. All the numbers together is 1 over 12. And I've got k squared. Oh, then you'll match with this one. So you can just take the answer that you just got, which was 1 over 12. And I'm going to say 2 over 3 minus 1 over 12. So I get 7 over 12 for my k squared. Just remember, I just got it from this one and this one. They were like terms. And then here I've got 2k minus k. Remember, this negative will distribute. So this is just plus k. And then I've got 1 minus a quarter is going to be plus 3 over 4. And please remember, it's still equal to 13 over 12. Yo, this looks like a trinomial, especially if I can times everything by 12 to get rid of the denominator. I'm going to have then 7k squared plus 12k. If you want to, you can type in 3 over 4 minus 13 over 12 first, and then just times it by 12, because remember, everything was times by 12 to get rid of denominator. And then it's mode 5-3. What I mean with mode 5-3 is you remember that you can solve any trinomial by going mode 5-3, and then you just type in for me the coefficients 7, 12, negative 4. 7, 12, negative 4. I do get 2 answers. I get 2 over 7. Let me just see how accurate we are. 2 over 7. Yes. And then I do get another one, but there's probably a reason why they discard it. So I'm just going to write down the 2 answers. I just wanted to make sure that we are correct. Okay, so the answer that I got, you get it like this, 2 over 7. You can say k is equal to 2 over 7, but the bracket needs to look like this. The other answer I get is negative 2. Oh, I do remember now when we started this, they did say k must be a positive constant. So that's probably why they went not applicable for the negative 2. Okay, that makes sense. Let me just show you what I mean. I did remember reading this. K is a positive constant. Okay, fantastic. I think we've got, what is this? One more question to go. Yes, question 11. We're almost there. And like I always try and say, refocus between questions. Don't let the previous question affect your next question. Breathe deeply and believe that you can do this. 11. We've got a circle with center C. I know circle work is new syllabus work, so not everyone's very fond of it and used to it yet. So this is 8 and 4. Oh, just by the way, if they give it to you in that form, you can read off your center. The center will be 8 and 4. The signs just need to change. And by the way, the 100 is going to represent r squared. So your r is actually 10. They say that there is a point T somewhere outside your circle. I'm just going to try and draw this because we might need it. So T is negative 6 and 6, and we need to show that that point is outside the circle. So I just sort of plotted this. Oh, this is T. Check how my center is looking. Very nice. I got my coordinates from my equation. You can just sort of aim for something that's negative, because obviously this negative 6 is less than 8. 6 is going to be, 6 is actually going to be more than 4. So maybe we should rather draw it a little bit up. So let's just draw a circle. Doesn't really matter. I'm just going to aim here rather. So t is going to be -6 and 6. How do we prove now that this is outside my circle? I know I'm drawing it, but how do we prove that it's outside my circle? I would love for you to notice that your radius is still 10. We have a radius of 10. We can maybe work out what this distance is from my C to my T. And if that's bigger than 10, you have to lie outside. I want to remind you of the distance formula. Distance formula is square root of x2 minus x1 squared. This is not on your formula sheet, unfortunately. Oh, I don't know what I wrote there. And then we sub in the coordinates. Let's do this. X minus x1, double negative, y minus y1. Quickly work out for me what this is. This is the distance from C to T. I'm thinking it's definitely going to be bigger than 10. They get square root of 200. Or you could have probably, if you did this on the calculator, I think you would have gotten 10 root 2. Because the calculator always simplifies your surds. Yeah, 10 root 2. Now, don't just stop there. I know you're aiming, and you were aiming for something bigger than 10, but now make a statement and say, hence, you are outside the circle. You can't just now stop because you got what you wanted. You have to say what that means, that T does lie outside the circle. Then they say, two tangents from T to the circle are drawn. Show the angle between one of the tangents and CT is 45 degrees. Okay. So they say two tangents are now drawn from T. So we just need to be a little bit accurate here. Try and do that. So two tangents are drawn, and we need to show that the angle between the line CT and one of my tangents, so it could be this one or this one, doesn't matter, that you need to prove that that is 45 degrees. You are seeing which angle I'm talking about, eh? This angle. Many methods, but the one that jumps up and wants to help me in this stage is that theorem that says your radius is perpendicular to your tangent. So we do know that this is 90. We do know that this is 10. We do know that this whole side was actually 10 root 2. So I'm just going to write it like that. That whole side was 10 root 2. Are you seeing maybe some trig happening? We've got a 90, so we're allowed to use SOHCAHTOA. I don't know if you were taught it like that. SOHCAHTOA, sine, opposite hypotenuse, adjacent hypotenuse for cos, tan, opposite adjacent. It helps to remember the ratios. So for this angle, I'm dealing with opposite over adjacent. No, opposite over hypotenuse because it's opposite the 90. So opposite hypotenuse is sine. So if you really wanted, let's call this T1. If you really wanted sine of T1, you'd go opposite over hypotenuse. And if you want to get T1 alone, you need to go arc sine. So I'm just going to go shift sine of 10 over 10 root 2. I get an angle of 1/4 pi. Oh, but you can go back to degrees. Even mid-sum, you can go back to degrees. You can just go shift setup 3. Then you're in degrees again. Press equals 45. Exactly 45 degrees. I'm so happy to see that. Okay, so that is now 45 degrees. That helps. Next question. That is exactly 45 degrees. The two tangents touch the circle at A and B. Find the equation of AB. Okay, so the two tangents, they're talking about where it touches, will touch at A and B. Okay, this is quite interesting because remember, when you do have tangents touching, they will be the same length. Okay, they will be the same length. And when you connect them, and you connect your, what do you call it? center, why am I losing my words now? It's because I'm getting tired. If you connect your tangent to your center, this is basically like a kite, eh? Can you see that? It's almost like a kite. But this is a kite with extra things because I know that these are equal. And I know that with a kite, this will happen. But this is a special type of kite because we've got a 90 there. I know this is not drawn to scale. But this is a 90, this is a 90. So this actually becomes a square, if you're with me, a very ugly square. Because we've got the 90 and halfway, and we know that all of these are the same size. So what happens now is we can work out this line's gradient by working out this line's gradient and flipping it. Yo, I hope I didn't lose you there. If you work out the gradient of TC, let me do it close by. If you work out the gradient of TC, you will be able to just use your coordinates, y2 minus y1, x2 minus x1. I get -2 over 14, -1/7. That means the gradient of AB, which is the line we're trying to get to, is just going to equal 7. Let's see if we are accurate so far. Just going to give me 7. Yes. And then they do something interesting to get a coordinate on here. This is a little bit of a messy sketch, but I hope you're still with me. To get an equation of AB, we need a coordinate somewhere on AB. And to do that, I would have suggested getting the midpoint of CT. Because remember, this is a square, so it's not drawn to scale, but it still means that if this is halfway, this will also be halfway. So we need the midpoint of CT to find a coordinate on AB. So the midpoint of CT, just below where you did gradient just now, midpoint you take x1 plus x2 over 2, y1 plus y2 over 2. I get 1 and 5 is my midpoint. Let's use that into the straight line equation. Straight line equation, I'm just going to write it here. Y equals mx plus c. I've got my y, I've got my m, I've got my x, and you can work out your c. I was hoping for a c of -2. And then if you look at the equation, that's the equation I was looking for. That's the equation of AB. Last question for today. They want the x coordinates of A and B. Now remember, I know my sketch is a little bit not drawn to scale, but something to notice here is that you have point of intersection. A and B are basically where this line that you just found and the circle intersect. So when you write down your circle again, I want to remind you that they gave you your circle and you have got your straight line. So you want to know where this straight line intersects your circle. So I need you to quickly go get your circle again from the paper. The very first question, go back. They gave you your circle. X minus 8 squared plus y minus 4 squared equals 100. We normally try and set things equal to each other when you do point of intersection, but if they look like this, you're not going to get y alone in a circle. No, it's going to be too messy. So I'd rather take my straight line and I want to say intersect, but it's because it's intersecting. I want to sub it into my y to find point of intersection where this line meets this circle. Okay, so then all I need to do, you sub it in, it's 7x minus 2 into that y minus 4. Don't forget your other goodies. And then you need to solve for x. Don't make mistakes now at this late stage. I'm just going to quickly simplify that for myself because we need to square these brackets. You can't just square root. No. Let's square this bracket. Square the first, square the last. That times 2. Square the first, Square the last. That times that, negative 42 times 2, negative 84. And that, you can 100, you can just bring over. Let's see what trinomial you make, because I do need this to become a nice trinomial. Like terms, x and x, so this becomes 50x squared. This becomes negative 100x. Okay, those cancel out because it's 64 plus 36 is 100 minus 100, gone. So if I take out a common factor, maybe you can take out a common factor 50x. I get x minus 2, which means I've got two answers. X is 0 and x is 2. Let me see if we are accurate. Yes, x is 0 and x is 2. Fantastic. We made it through this paper and we are stronger for it. I want to thank you for being on this journey with me. I hope that I answered all your questions. There are alternative methods to some of the questions, but I will be doing them step by step in every video. So please subscribe if you like this. I know maths is not really everyone's favorite, but I would love to do some more papers with you. Okay, bye.